let me another sheet of paper here. And I want us to look at where the law of sines comes from. So you don't need to write this down. It's not something that I'm going to ask you to reproduce on a test. But I think at this level of math, you need to understand where some of this stuff comes from. And the proof of this is not that complicated. You should be able to kind of follow along with me here. Okay, so I'm going to label this A, B, and C, side A, side C, and side B. And I'm going to draw in a perpendicular line from a point up here for angle C down here. So I've got now two right triangles. Well, I can use my definitions of sine, cosine, and tangent. You know, it's opposite over hypotenuse and adjacent over hypotenuse and all of that to write expressions for this. Oh, one other thing I want to do is I'm going to label this height here as H. And I'm going to look at angle A here. And I'm going to find the sine of angle A. Remember, sine is opposite over hypotenuse. So I'm looking at this triangle here. So it's going to be H over B. And I'm going to solve this for H, right? Multiply both sides times B. So I get B times sine A equals H. Now I'm going to do the similar thing over here with this triangle. And I'm going to find the sine of B is, again, opposite over hypotenuse. So H over A. So A times sine B equals H. Now this is kind of like that bonus point or bonus question that we had on a test earlier in the year where I could figure out these heights, and I know that I have an expression for the height here, an expression for the height here. So these two things must be equal. This and this are both equal to H, so they have to be equal. So I know that B sine A equals A sine B. Now I can divide both sides of my equation here. By AB. So here the B's are going to cancel. So I have sine A over A. Here the A's are going to cancel. I have sine B over B. Now, if I would turn this triangle differently and make a different height here, and then do the same thing again with the two triangles using A and C, I would eventually get to where that I also have this as well, right? So I have the sines over the opposite side, that ratio are all equal. And I could also flip all of these upside down, so I could have the sides on top and then the sines on the bottom. Does not matter to me. think this is the one that's, yeah, this is what is on your reference sheet. But I'm going to be using both of these as we go through our problems, right? So this is a proof of where the law of signs comes from.